Hi fellas, this is Chemaddicts again to the solution. Welcome back to another video tutorial. Now we gonna solve the second part of this question. Okay, so let's get started. So in here, let us at first read the question. Where is my pen? Here is my pen. So here, previously we have discussed about this experiment, how to measure, how to follow the rate of this reaction, how to follow the rate of this reaction, and the measurements that we would make in order to calculate the rate of this reaction. Okay, so now the question has asked the rate equation for this reaction is this. Okay, so what are the units of the rate constant? Okay, so in the rate equation, so this is the rate equation as we all know. So in here, this is, sorry, in here the order of this thing is 1. Since there is no power, so we should consider this thing as 1. So the order of N2O5 is 1. So in the rate equation, here this is the concentration of N2O5 is raised to power 1. So the order of N2O5 is 1. Okay, here is the order of first order with respect to N2O5. So here this is the rate constant. This is the rate constant. Okay, this is called the rate constant. Okay, so here they have asked what are the units of the rate constant. So let us now examine this thing here. So here the rate, here the unit for rate is this. Unit for rate is mole per dm cube per second. Okay, here the unit for concentration of this thing is unit for concentration, that is NO, sorry, N2O5. N2O5, that is, since the order of N2O5 is 1, so this thing should be mole mole per dm cube. Okay, so if we if we want to make K the subject, so if we want to make K the subject, okay, so it will look something like this. So mole per dm cube per second, mole per dm cube. Okay, the unit of this thing is here. We have just moved this thing over here. So ultimately K is equals to rate divided by concentration of this. Okay, so now this thing gets cancelled out. So the only unit that we are left here is per second. Sorry, per second. Okay, so the answer should be per second. So I hope that you have understood this question. The question was pretty straight. Okay, the question was pretty straightforward. So if you have any confusion, please let me know in the comment section. Okay, so now let us move on to the next question. All right, so a suggested mechanism for the reaction is this. So this is the first step, for this reaction. So here nitrogen dinitrogen pentoxide reacts to form nitrogen dioxide and nitrogen dioxide. Here nitrogen this nitrogen dioxide and nitrogen trioxide reacts to form nitrogen monoxide, water, and nitrogen dioxide. Here nitrogen monoxide reacts with dinitrogen pentoxide to form nitrogen dioxide. Okay, so let us read the question. Label these reactions fast or slow and explain how your labeling is consistent with the rate equation. Okay, So let us once again look at the rate equation. So this is the rate equation. Rate equation. So rate equation is rate is equals to constant k, rate constant k, then N2O5 raised to power 1. Since the order of this reaction is 1, since the overall order of this reaction is 1, so the only particle would be involved in the RDS step is nitrogen pentoxide. Okay, so here the only step that involves only one particle is this one, step number 1. So since there is one particle involved, so this must be the rate determining step. Since one particle is in the rate determining step according to the rate equation, here since here dinitrogen pentoxide is present, since here only dinitrogen pentoxide is present over here in the rate equation, so in the RDS step the particle should involve this dinitrogen pentoxide. So the only reactant would be present here is the only reactant that is present in the RDS is dinitrogen pentoxide. The only uh, what the only reactant that is present here in the present the only reactant that is present in the rate determining step is this. Okay, so this is in the rate determining step. So this is in the rate determining step. Well, let me write this clear. So this is the rate determining step. Since one particle is present in the rate determining step, so this should be the RDS. And as we all know that rate determining step is the slowest step of all. It is the slowest step of a multi-step mechanism. Okay, since it is the slowest step of the multi-step mechanism, so here this should be slow. Okay, and since there is only one particle possible over here, so this step should be slow and other should be fast. Okay, since the RDS is the slowest of all step, here 1 2 3 is the slowest of all step in here. One is the slowest step of this. Since the first step is the slowest of all these three steps, so this should be the RDS and the other should be fast as usual. Okay, so we have labeled this reaction for fast or slow. Explain, they want us to explain how your labeling is consistent with the rate equation. So they want us to explain this labeling, so why we have labeled this thing over here. So here we have already achieved 1 mark over here. Yahoo, we have achieved 1 mark. Still 2 marks to go. Okay, 2 marks to go to achieve 3 marks. Okay, so the reason should be like this. Since the overall order is 1, okay, since overall order is 1 and the only species that is present here is dinitrogen pentoxide molecule in the rate equation, so the first step would be the rate determining step. Okay, the first step would be the rate determining step. That's it. Since the overall order since the overall order is 1, okay, and the only species here is N2O5 molecule is present in the rate equation. Okay, so since the only N2O5 molecule is present in the rate equation, so the first step would be the rate determining step. So the first step would be the rate determining step. Okay, determining step. Since only since here the only species is N2O5 molecule, so the first step would be the rate determining step. So let me tell the answer once again. Let me repeat this answer for this question once again for you. Since the rate since since the overall order is 1 and the only species here is N2O5 molecule is present in the rate equation, so the first step would be the rate determining step. Okay, so that's the answer to this question. So in here we have achieved 1 mark, and in here we will achieve 2 mark. So this is the answer of 2 mark. Okay, this is the 2 mark answer to this question. Okay, so if we mention that the overall order is 1, okay, and the only species here is N2O5 molecule is present in the rate equation, so the first step would be the rate determining step. So if we add this element to this answer, then we will obviously achieve 2 marks for this question. Okay, well fellas, that's the end of today's tutorial. So if you have missed the previous episode, I will put the link to the previous episode at the end of this lesson, so you may watch them if you find this interesting. Okay, well fellas, signing out for now. So stay chilled, best of luck, and as always, peace with chemistry.